So hi everyone, myself Orkajitide, and today we are going to look closely about an algorithm that is closest pair of points. The problem is basically simple. You will be given n number of points in a 2D plane, and you have to tell. See, this is a 2D plane, and here are many points, and you have to tell which is the closest point, closest pair of points. Suppose this is the closest pair of point here. This is x-axis, this is y-axis, and I know there are many videos in YouTube that explains this algorithm, but the only catch is it is very difficult to understand about the 2D strip and why we consider only the next 7 points from the 2D strip, and I will be focusing on that. Before moving on to that, I will be just giving you an overview of the whole algorithm. So without further ado, let's get started. So you are given and 2D plane, and you are given n number of points. Suppose the points are 1 2 2 3 3 4 5 10. Suppose these are the points, and what you need to do is you need to find which pair is the closest. Suppose this pair is the closest in this. This may not be the closest, but I am assuming this is the closest. So how you are going to find that which pair is the closest? You can simply do one thing. You can think about the brute force way, that which pair is the closest. And what is the brute force way? It's comparing each and every points with each other. Suppose I will compare. Suppose there is 1 2 2 3 3 4 5 10. Suppose there are only 4 points. So what I will do, I will compare these 2 points and find their in Euclidean distance. I will find this. I will consider these 2 points and find their Euclidean distance, and then these 2 points. Then I'm going to find these 2 points. I'm not going backwards because these 2 points are already being considered, and distance is not like a vector quantity. So um, if I consider this first and this second, or this first and this second, both are same. So I'm going to consider these 2 points, and then I'm going to consider these 2 points. Next, for this point, I'm going to consider these 2 points, and likewise, in a brute force approach, you are going to consider each pair of points and find their distance and return the minimum of them. So what will be the time complexity of this thing? The time complexity will be n square. You can easily guess that the time complexity is n square. But if you are given a lots of points in a 2D plane, then n square can be, sorry, this is x-axis, n square can be a bit linear algorithm. It We need to look for something which is less than n square, and we can think of divide and conquer algorithm. Divide and conquer algorithm will basically do this job, the same job, for about n log n. And how they're going to do it, how divide and conquer is going to do it, let's look closely. So suppose you are given 5 points, suppose n points. What you are going to do, you are going to sort them according to their x coordinate. So sort according to x coordinate, and after sorting them according to x coordinate, you are supposed to get this. And after sorting them according to their x coordinate, what you will do, suppose you get this way. Suppose the points are like this way. Here is a point, 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 and this is your array sorted according to uh, the x coordinate, and you are going to find the middle. suppose there are n points, the n by 2th index or n by 2 minus 1th index, if it goes from 0 to n minus 1, that will be the midpoint. And you are going to do a partition here. See, look closely, this is very much important. And you have divided the whole plane into two parts, the left part and the right part. And what you will do is, you are going to find this will be done recursively, and you are going to find the smallest distance, suppose dl, from comparing from the left part, and the smallest distance dr from the right part. And you need to find out the minimum among dl and dr. Suppose that is d, the minimum of dl and dr. But is this the minimum of, is this the closest pair of all the points? There can be one thing, suppose this is the partition, there can be, suppose some point like this, which can be, suppose this is d naught. D naught can be lesser than d, but we haven't got it calculated because they lies on the other parts of the partition, on the other parts of the line that we have chosen. So what we are going to do is, so you think that we are going to compare each and every point on each of the partition. No, that is not the case. We are going to optimize this, and how we are going to optimize this is, suppose this is the line, we are going to consider a strip of d length, this side of d length, this side of d length. And we are why we are considering a strip of length 2d from the partition, this side length d, this side length d. The d, remember, is the minimum of dl and dr. Why we are considering this? Because suppose here is a point on the right part, and here is a point on the left part that is beyond this d, that is slightly outside than this part. And this distance, which I have shown in dotted line, will always be greater than d. This distance will always be greater than d, because see, I have, this strip is of d length, and this distance will always be greater than d. So we don't need to consider any points that are beyond the strip. We need to focus on the strip only. And the beautiful part is, we are going to further optimize it. How we are going to further optimize it? See, this is the d, this is a zoomed in version, this is the d, this is the d, and this is the x-axis, this is the y-axis. Is the video recording going on? Yeah. So what we are going to do, we are going to now scan this whole strip and store the points in another list. Suppose there are this much points, and we are going to scan this whole 2D strip and store the points in another list. And what we are going to do, we are going to sort them according to their y-axis, y coordinate. We're going to sort it according to their y coordinate. And after sorting it according to their y coordinate, suppose we got this thing. And what we are going to consider is, now we are going to consider any point and the next 3, 4, 3, 4, 5, 6, 7, and the next 7 points. Suppose here are many points. We got this many points after scanning the strip, and we are just going to take, suppose for the first comparison, we are going to take this and the next 3, 4, 5, 6, 7, and the next 7 points. For this point, we are going to take this and the next 7 points. Why only next 7 points? there is a very good reason to only take the next 7 points. Otherwise, if you not take the next 7 points, you will be considering all the points. You will be have to go through the brute force approach, and through the brute force approach, if there are many points in the strip, suppose there are points in the order of n in the strips, the time complexity would go up to n square. So for this reason we are going to take this. And why we are only considering the next we are considering the next 7 points, and then again where we will look at this point and the next 7 points, because look closely. If we will divide our strip, suppose this is our first point after sorting it according to y-axis, and we are going to focus on this box only and not anything else. This length is d, this side is 2d. So if I break it down into 8 small boxes, each boxes will be of size d, of length d by 2. So what will be the diagonal? The diagonal will be d by root 2, which is lesser than d. D by root 2 is obviously lesser than d. So why I have taken the next 7 points is, suppose here is a point, and each boxes, there is no box which is which contains space from both side of the partition. Each boxes lies on other side of the partition. This is very, very important. And I'm going to consider the next 7 points, because suppose I consider this point, and I consider, see, in one box there can only be one point. Why there can only be one point? As if there are 2 points in the, suppose I consider that there are 2 points in a single box, so the distance between them will be at max d by root 2. If there are 2 points in a single small box, and d by root 2 is obviously lesser than d. So but we have already considered that the least distance in any of the side is d. So this is a contradiction, that in a single box we need something lesser than d, but in a single box, if 2 points contain, so the 2 points cannot contain in a single box, because the maximum, because we have already chosen the smallest distance between any 2 points is already d, and there cannot be 2 points lesser than d, but it shows that it will be lesser than d. So it is clear that in every box there will be a single point, and as in every box there is a single point, you can see that in every box there will be a single point. And after calculating all the distance, you are good to go. You are good to say that, for example, I will be considering these points, I will be considering the next 7 points in this box. And you might, and you have cleared the confusion that why we are all only considering the next 7 points. And suppose I consider the 8 point will be here, and that will be greater than d. See, from this point to this point, that will be greater than d, and taking something which is greater than d is of no use, right? So we are going to divide the strip of this small box, and uh, a rectangle of breadth d and d by 2 every time, sorry, 2d and d every time. And we are going to calculate, we are going to take the first and the next 7 points. So we are going to calculate just the 8 points, and it doesn't go to n square. It goes like, for every point, if there are k points in the list of the strip, k into 8, because in each operation you are going to compare with 8 other or 7 others, so 8 is a constant. So k into c, it comes big of k, right? And the whole algorithm, as it is a divide and conquer algorithm, comes as n log n for sorting, for like recursively distributing everything. The only thing which I think that is difficult to understand is this part, why we are going to take the next 7 points. So I think I have explained it, and I think you got it. If you don't, try to go through some like textual understanding or other videos. Thank you. Bye bye.